In this video, I'm going to cover the concept of percent yield. So I'll define what percent yield is. We'll look at how the percent yield in a chemical reaction is altered, and we'll go through a few calculations that allow us to determine the percent yield. So why don't we get stuck in? There's a lot of text on this page, obviously, so if you want to pause the video and read the text, that's maybe a good idea. I'll also sort of briefly explain what's going on in the text. So far in our calculations, we have essentially assumed 100% completion of the reaction. That is, we take a mass of something, say a mass of sodium, 22 grams of sodium, we add it to the water. So we add sodium to water, a reaction takes place. And using our stoichiometry, using our mole ratios equation factors, we predict a mass of sodium chloride that would be produced. So we're predicting the mass of the product. This would be then known as a theoretical yield. That is, in theory, if all 22 grams of the sodium reacts with the water, an amount of sodium chloride that we calculate would be produced. So in theory, we get the mass of product we've calculated. However, what if we really went ahead and mixed 22 grams of sodium in water? So this is an experiment. So we mix 22 grams of sodium in water. We evaporate off all the water after the reaction is complete. We allow the salt to dry. We've got to get rid of the water. And then measure the mass of the sodium chloride collected. The mass we obtain would then be known as an experimental yield. Not surprisingly, the experimental yield can only be obtained by experimentation. The theoretical yield is only obtained by calculation. Now, there's a variety of reasons why theoretical yield and experimental yield are not the same. So why don't we have a look at some of those? Oh, sorry. First of all, quick definition. There they are again reiterated for you. Theoretical yield is the mass of product that should be produced from a known mass of reagent, whereas the experimental yield is mass of product actually obtained through experimentation. And so the percentage yield or percent yield is that relationship between experimental and theoretical yields. That is, it's a ratio between the experimental and theoretical yields. And there's the calculation from it. Percent yield equals experimental yield divided by theoretical yield times 100. And so that gets expressed as a percent. Now, why is there discrepancy between experimental and theoretical yields? Well, there's a few reasons why experimental is smaller than theoretical, and usually it's smaller. So one reason, reactions may not go to completion. That is, there's some reactant left, and if it's limiting reactant, we know limiting reactant will dictate how much product's produced. So if not all the limiting reagent is used, you're going to have a lower amount of product produced. So the mass would be different. Experimental yield would be less. The presence of side reactions. Side reactions can occur under extreme conditions where it's really high temperature and or really high pressure. And in that case, some of the reactant produces a product you weren't expecting. And if you get a product that you're not expecting, it means you're not getting as much of the product you expected. So again, your experimental yield will be smaller. Some product is lost during separation. This is fairly common. It's usually done very carefully, but if you're a little bit careless, you spill some of the product, you lose some of the product, and therefore by the time it gets around to getting a mass of that product, you have less than you actually collected. And that's going to give a smaller experimental yield. And finally, impurities in your reagents might give rise to problems. Impurities would be things that are not what you think they are. So you're limiting your reagent to, say, sodium chloride, and you have some potassium chloride in there. Well, that's going to react differently and not produce the product of interest. So these impurities, again, will cause less of your product to be produced based on a measured mass, and that's going to give rise to a smaller percent yield. There's only one major reason why the experiment is greater than the theoretical yield, and this would be contamination of the product through separation errors or simply mass errors, but it's not uncommon. I mentioned before that if we want to get an amount of sodium chloride collected experimentally, we have to dry the sample. Well, if you don't dry it fully, there's going to be some water left over in with the sodium chloride. That water would add to the mass of your product, and your experimental yield would in all likelihood be quite a bit higher than the theoretical yield, and so you'd have a higher percent yield, higher than 100%. But this is less common. Okay, let's straight into some calculations. Here we go. 2 grams of magnesium chloride is added to solution contains an excess of copper 1 chloride. So what are the products of this reaction? The question is essentially just asking you to write a balanced chemical equation. Magnesium chloride is added to solution containing copper 1 chloride. So if you want to go ahead and write that out, you can pause the video and write that reaction and see if you get the right one. So there's the correct equation. Magnesium plus CuCl, copper 1 chloride, yields magnesium chloride plus copper, and when we balance it, we get 2 copper 1 chloride, 2 copper, single displacement reaction. Now, if the theoretical yield of copper for this reaction is 10.4 grams, theoretical yield is 10.4 grams, and the actual yield is 2.9 grams. Actual yield, this is the same as experimental. So here we have the two values we need for our calculation, and so theoretical and experimental, we divide the experimental yield into the theoretical yield. And so there's an example of that calculation. Experimental yield divided by theoretical yield times 100. 2.9 grams, our experimental yield, divided by 10.4 grams, our theoretical yield we would get from a calculation, times 100. 28% is our experimental yield. Here's another example. So a chemist tries to synthesize dichloromethane CH2Cl2 by mixing chloromethane CH3Cl with chlorine gas, expecting the following reaction to proceed with no side reactions. So here's our reactants, chloromethane and chlorine gas. Given initial mass of 7 grams of chloromethane, so initial mass is 7 grams. With excess chlorine, so we know it's not a limiting reagent problem, what is the percent yield of dichloromethane? So we're looking for a percent yield of this particular product. And so we have all the information we need. 5.9 grams of dichloromethane was obtained. This is our experimental yield, was obtained. But first we have to calculate the theoretical yield. We do that with the initial mass of chloromethane given, 7.0 grams, with excess chlorine. So we know it's not limiting, so we're going to use that 7.0 grams. So let's go on to the calculation. So go ahead and calculate a theoretical yield. So we might pause the video for a minute to try to do the calculation of theoretical yield and see how you go. So there is the theoretical yield for our dichloromethane. Here's our product of interest, dichloromethane. So we know a mass of 7, molar mass, we have to calculate. We're looking for the mass of dichloromethane. There's the molar mass of dichloromethane. So the number of moles, mass divided by molar mass, 0.1386 moles of chloromethane. Because it's a 1-to-1 ratio, we have the same number of moles of dichloromethane. And then we multiply dichloromethane by its molar mass, we get 11.8 grams. So there's our theoretical yield of chloromethane, 11.8 grams. So now we can go ahead and calculate percent yield. So again, pause the video if you want, try to calculate the percent yield and see what you come up with. And so there is the percent yield calculation. The experimental yield, which you calculated, is 5.9 grams, divided by the theoretical yield, which we determined from our calculation, times 100 gives us our percent yield of 50.1%. So that is how you go about determining a percent yield. You have a calculated value, that's the theoretical yield. You need to be given the numbers and the reactants products to do that, and you need an experimental yield, which you will be likely to be given, because we're not going to be doing questions like this having first gone into the lab to get a yield. So that concludes this video.